When working with strings, we often need to extract substrings. For example, if a string contains a phone number, we may want to extract the area code. In this lecture, I'll introduce two techniques, indexing and slicing, and we'll use those to extract substrings of the strings we're working with. In this lecture, we'll use the string learn to program as our running example. Each character of a string has an index, which is its position in the string. So the string at index 0, indicated using this bracket notation, is the L. At index 1 of the string, we have an E. At index 2 is the first A. Notice that 0 is the first position, not 1. We start counting from 0. We can also use negative indices to count from the end or from the right-hand side of the string. So the string at -1 is the M. At -2 is the last A. At -3 is the R, the last R. So as we've seen, using an index, we can extract parts of the string one character at a time. But we can extract more than one character using another approach called slicing. With slicing, we provide a starting index, followed by a colon, followed by an end index, and that gives us a substring from the start index up to, but not including, the ending index. For example, we can get the string from position 0, index 0, up to, but not including, index 5, and that gives us a string learn. From index 6 up to, but not including 8, is the 2, and from index 9 up to 16 is the word program, string program. 16 is equal to the length of the string, so an alternative would be to start at index 9, but go up to len of s. Len is a built-in function that returns the length of the string. So this expression is equivalent to the one above. Another alternative would be to go from 9, put the colon, and omit the ending index, in which case the default is to go to the end of the string. So this is also equivalent to the two expressions above. The starting index can also be omitted. So for example, we can include colon and go up to index 8. We can also omit both the starting and ending indices, and that gives the entire string. We've seen that negative indices can be used for indexing, and they can be used for slicing as well. Let's just get the substring from index 1 up to, but not including, 8. An equivalent expression is to get it from 1 up to, but not including, -8, or to go from -15 up to, but not including, -8. So those three expressions are all equivalent. The slicing and indexing operations do not modify the string that they act on. So the value that S refers to is unchanged by the operations above. In fact, we cannot change the value of a string. Operations like the following result in errors. If I take the string at index 6 and try and set it to D, I get an error. Similarly, if I try to modify the string from index 9 up to 16 and have it refer to run, an error also occurs. But imagine that we'd like to change string S to refer to learned to program. Here's one approach that we can take. We can use the current value of S and get the word learn, concatenate that with ed to make it learned, and concatenate that with the rest of the string, which is to program. That evaluates to give learn to program. And now that we have this new string, learn to program, we can have S refer to that instead of its old value. Notice that we didn't modify the string that S originally referred to. We can't modify it. Instead, we created a new string and have S refer to that new string.